In this section, we will be studying the relationships between variables. Various questions on the ACT require you to understand how variables affect one another. In addition, a major part of the test is interpreting graphs. Therefore, it is important to understand some basic graphical concepts, such as slope and y-intercept. The first thing we're going to talk about here is relationships between variables. The first type of relationship you can have is called directly proportional. And what happens is as one variable increases, the other variable increases as well. Or as one variable decreases, the other variable decreases as well. So for example, maybe if you have a graph that looks something like this, where x is your horizontal axis, y is your vertical axis, if both variables are increasing for a direct relationship, it would look something like that. On the other hand, inversely proportional means as one variable increases, the other variable decreases. So for example, if we draw the same graph, maybe as my x variable increases, my y variable has got to decrease. So it will look something like this. All right, a real quick math review. Slope, remember, is the rise over the run, or it's y2 minus y1 divided by x2 minus x1, or delta y over delta x. One good thing to do in science is to keep your units on your slope. The slope generally tells you something about the system in which you do the experiment. Another math term you may have heard of is the y-intercept, which is abbreviated by a b, and that's where the graph crosses the y-axis and your x value is going to be 0. This may or may not have significance to your experiment. All right, so let's just do one example talking about those concepts. Over to the right here, you're going to notice this is a velocity versus time graph. So on your y-axis, you have velocity, and that's in meters per second here in parentheses. On your x-axis, you have time, and the units on that it would be seconds here in parentheses. So the first thing you can sort of notice, as the time is increasing on your x-axis, your velocity on your y-axis is also increasing. So you would have a direct relationship between the two variables. The curve is going to be a straight line, so that's going to tell you that, first of all, the velocity is going to depend on the time. Therefore, the velocity is increasing at a constant rate with each time interval. If we were to calculate the slope, we want to choose 2 points on the line. I'm just going to choose this point here and this point right here. The easiest way to figure out slope is do your rise over your run. So my first point starts at 2 on my y-axis, and it goes all the way up to 10. And then on my x-axis, it starts at 0, and it goes all the way over to 10. So if I do my delta v over delta t, which is just like delta y over delta x, my rise, I go from 2 to 8, or 2 to 10, so that's 8 meters per second. And my run goes from 0 to 10, so that would be 10 seconds. So my slope would be 0.8 meters per second squared. Notice how the units on your slope are meters per second squared. So the slope is actually going to tell us, in this case, an acceleration of whatever object that may be. To get your units on your slope, notice rise is meters per second, and then your run's in seconds. So you got a meter per second, which gives you this meter per second squared. All right, now let's say we were to have like a steeper line on our graph. Maybe something like this. What would that mean about the object? Now let's just think about this. If I got a steeper slope, that would mean that this velocity would be changing at greater rates for each unit of time. So that would mean that that object has to have a larger acceleration than this previous object. If the slope would be more gradual like this, this thing would be changing less velocity per unit time, so it would have a smaller acceleration. All right, the next point I want to talk about is the y-intercept. You can take a look at this original object here. The y-intercept was 2. So that means the velocity is 2 meters per second when the time is 0 seconds. One question you may see is, what would the velocity be maybe after 20 seconds? So there's a couple different ways you can answer this question. First way would be, take this line and try to extend this line further. You know it's going to be a straight line, and just sort of extend your graph over and estimate where it's going to hit. Another way you could do it is look at your velocity. So your velocity is increasing by about 8 meters per second each 10 seconds. So for example, I start at 2 meters per second. After 10 seconds, we said we're at 10. So it went 8 meters per second more in that 10 seconds. So after 20 seconds, it's going to go 8 more meters per second. So if I was at 10, then my final velocity should be 18. In conclusion, how variables relate to each other and slopes of graphs are important to interpreting data in experiments that may be given to you on the ACT.